Good morning. Today we have courses about intro to sensors. We started with the overview. What are sensors? Commonly detectable phenomena. Physical principle, how sensors work. Need for sensors, choosing a sensor, and we termined with examples. We started with definition. Sensors, it's American National Standards Institute. Definition of sensor. Sensor are the device which provides a usable output in response to specific measured. We have input signal. And then we have sensor. At the end, we have output signal. A sensor acquires a physical quantity and converts it into a signal suitable for processing. Example, optical, electrical, and mechanical. Nowadays, common sensor convert measurement of physical phenomenon into an electrical signal. With active element of a sensor is called a transducer. What are transducers? It's a device which converts one form of energy to another. When input is a physical quantity and output electrical, we have sensor. When input is electrical and output a physical quantity, we have actuator. For example, for the sensor, we have physical parameter and we have electrical output. For the actuators, input electrical and output is physical. Example, piezoelectric. We have to convert the force to voltage and voltage to force. Ultrasound, we have microphone and loudspeaker. Commonly detectable phenomena. We have biological, we have chemical, we have electric, we have electromagnetic, we have heat and temperature, we have magnetic, we have mechanical motion, displacement, velocity, and acceleration, etc. We have also optical and radioactivity. This is the common conversation methods. We start with physical. We have thermoelectric and thermoelastic, thermomagnetic and thermooptic, photoelectric, photoelastic and photomagnetic. We have electroelastic, electromagnetic. We have also magnetoelectric. For chemical, we have chemical transport, physical transformation, electrochemical. For the biological, we have biological transformation and physical transformation. This is the commonly measured quantity. Stimulus acoustic, we have the quantity wave, amplitude, phase, polarization, spectrum, wave, and velocity. For biological and chemical, we have fluid, concentration, gas or liquid. For electric, we have charge, voltage, current, electric field, amplitude, phase, polarization, conductivity, and permittivity. For the magnetic, we have magnetic field, amplitude, phase, polarization, flow, and permeability. For the optical, we have refractive index, reflectivity, and absorption. For the thermal, we have temperature, flow, specific heat, and thermal conductivity. For the mechanical, we have position, velocity, acceleration, force, strain, stress, pressure, and torque. Then we have physical principle, for example, Amperator law, occurring conjecture in a magnetic field experienced as a force. Example, we have galvanometer. Carry wireless law. This is a transition temperature at which ferromagnetic materials exhibit paramagnetic behavior. For Faraday law of induction, a coil resisting a change in magnetic field by generating an opposition. We have voltage and current. Example, we have transformer. We have also photoconjunctive effect when light strikes certain semiconductor materials. The resistance of the material decreases. Example, we have photoresistor. Then we have to choosing a sensor. For environmental factors and economic factors and sensor characteristic. We have temperature range. Economic factor is cost. Sensor characteristic is sensitivity. Humidity effect, we have availability and range. Corrosion, we have lifetime and stability. We have size, repeatability. Averaging protection, we have linearity. Susceptibility to EMF interference, we have error. Rigidness, we have response time. Power consumption, we have frequency and response. And we have also self-test capability. What we have need for sensors? Sensors are pervasive. They are embedded in our bodies, automobiles, airplanes, cellular, telephone, radio, chemical plants, and industrial plants, and countless other applications. Without the use of sensor, there would be no automation. Imagine having to manually fill Poland Spring bottles. Then we have motion sensors. Monitor location of various parts in a system. We have absolute, relative position, angular, relative displacement, and we have proximity, and we have acceleration. The principle of operation, we have magnetic, resistive, capacitance, inductive, eddy current, etc. We have an example, potentiometer, optosolator, and LVDT displacement sensor. We have also strain gauge, motion, stress, and pressure. A strain gauge is used to measure deflection, stress, pressure, etc. The resistance of the sensing element changes with applied strain. Wheatstone bridge is used to measure small changes in the strain gauge resistance. We have also temperature sensor, bimetallic strip. We have bimetallic strip. Their application are thermostat makes or breaks electrical connection with deflection, temperature sensor, the RTD, resistant temperature device, RTD. Other temperature sensor, we have thermistance, is thermal, istor is resistor. Thermocouple, seek back effect to transform a temperature difference to a voltage difference. Capacitance transducer. Recall capacitance of a parallel plate capacitor is A, overlapping area of plates. D represent the distance between the two plates of the capacitor. Permeativity of air or free space. We have also the electric constant. The following variation can be utilized to make capacity-based sensor. We have change distance between the parallel electrodes, change the overlapping area of the parallel electrodes, change the dielectric constant. L'accelerometer. L'accelerometer are used to measure acceleration along one or more axes and are relatively insensitive to orthogonal direction. For their application, we have motion, vibration, blast, impact, and shock wave. Mathematical description is beyond the scope of this presentation. We have also for accelerometer. electromechanical device to measure acceleration forces, static forces like gravity pulling at an object lying at a table, dynamic forces caused by motion or vibration. How they work? Seismic mass accelerometer. A seismic mass is connected to the object undergoing acceleration through a spring and a damper. Piezoelectric accelerometer, a microscopic crystal structure, is mounted on a mass undergoing acceleration. The piezo crystal is stressed by acceleration forces, then production of voltage. Capacitive accelerometer consists of two microstructures, micro-machined features, forming a capacitor. Acceleration forces move one of the structures, causing a capacitor changes. Piezoresistive accelerometer consists of a beam or micro-machined feature who use resistance changes with acceleration. Thermal accelerometer tracks location of a heated mass during acceleration by temperature sensitive. What are accelerometer application? In automotive, we have monitor vehicle lateral roll, skid, impact, vibration, etc. To deploy safety devices, stability control, anti-lock, braking system, airbags, etc. And to ensure comfortable ride, we have active suspension. For the aerospace, we have inertial navigation, smart munition, unmanned vehicles. We have also sports and gaming. Monitor, athlete perform and endure, joystick, little. We have personal electronics, cell phones, digital devices. For the security, we have motion and vibration detection. In the industrial, we have machinery health monitoring. In the robotic, we have self-balancing. This is an example of helmet impact detection. We have two-axis joystick. We have we have three-axis accelerometer. We have the Segway. And then we have also the MX2125 accelerometer, how it works. A MEMS device consisting of a chamber of gas with a heating element in the center for temperature sensor around its edge. We have hold accelerometer level. Hot gas pocket rises to the top center of the accelerometer chamber. All sensors measure same temperature. Later of the accelerometer, hot gas pocket collect closer to one or two temperature sensors. Sensors close to gas pocket measurement high temperature. We have mixed 2125 electronic that compares temperature measurement and output pulses, pulse duration encoded sensor. And we have also the light sensor. The light sensor is used in camera, infrared detector, and ambient light application. Sensor is composed of photoconductor, such as a photoresistor, photodiode, or phototransistor. For photoresistor, we have light-sensitive variable resistor. Its resistance depends on the intensity of light incident upon it. We have under dark condition resistance in quite high, called dark resistance. Under bright condition, resistor is lowered, few hundred. Response time. When a photoresistor is exposed to light, it makes a few milliseconds before it lowers its resistance. When a photoresistor experiences removal light, it may take a few seconds to turn to its dark resistance. For the photoresistor exhibit a nonlinear characteristic for incident optical illumination versus the resulting resistance. And we have also magnetic field sensor. Magnetic field sensors are used for power steering, security, and current measurements on transmission lines. We have whole voltage is proportional to magnetic field. And we termined with ultrasonic sensor. Ultrasonic sensors are used for position measurements. Sound waves emitted are in the range of 2 to 30 megahertz. Sound navigation and ranging. We have sonar. The radio detection and ranging, we have radar. We have electromagnetic wave. For photogate, the photogates are used in quantum application, example, finding period of a period motion. Infrared transmitter and received at opposite ends of the sensor. We have also time at which light is broken is recorded. We are arrived at the end of this video. Goodbye, and in the second video. Thank you.